Hello everybody, this is Dr. Imran Aziz, and today we will discuss about wireless and wired communication, which one has more attenuation, because to many people it looks very obvious that wireless communication has more attenuation. So today we will discuss that. So we see a wireless link over here. We have a transmit antenna, and this is the gain of the transmit antenna, and on the right side we have a receiver antenna, and this is the gain of the receiver antenna. The power transmitted is Pt and power received is Pr, and distance between the transmit and receive antenna is R. Then we know from the Friis radio link from formula that received power is equal to gain of transmit antenna, gain of receive antenna, lambda square, the wavelength at the frequency of operation, over 4 pi r square into Pt power transmitted, and this is power in watt. And from here we see that the received power decreases as a function of 1 over r square. So as r increases, the distance between the antennas increases, the received power decreases as the function of 1 over r square. So if we know, go to the wired link and see that how the signal attenuates in a wired link. So we know that in a wired link, the RF signal attenuates at e to the power minus 2 alpha r, where alpha is the attenuation constant of the line, which is usually measured in decibels per meter. And as this attenuation is exponential for a certain value of r, when r exceeds to a certain value, we will see that this attenuation becomes larger than the attenuation over here. So this is the reason that for long distance communication, radio links will perform better than the wired links, because this exponential function will have more attenuation compared to this geometrical function. So we can say that this conclusion applies to all types of transmission lines, including coaxial lines, waveguides, and even optical fiber lines. So to understand it better, if we take an example, so if we have a communication link where the distance between the transmit and receive antenna is 5 kilometers, so two possibilities are evaluated. First is that a radio link operating at 28 gigahertz with gain of transmit and receive antenna 25 dB. So this is one option to have a radio link. The other option to have is the wired communication link using the coaxial line, where the attenuation of the line is 0.05 dB per meter. And if minimum required received power level for both cases is same, which option has more attenuation? If we see the solution of this example, so frequency of operation is 28 gigahertz, lambda is 0.0107 meters, gain it is given 25 dB, and which is 316. And if we suppose that received power level is 1 watt for both cases, then power transmitted can be found from this Friis transmission formula, which will be 3.45 10 to the power 8 watt. And if we calculate the attenuation from here, which is 10 log of received power divided by transmitted power, or in dB, we can just PR minus PT. So this is minus 85.4 dB attenuation in this radio link. And here we are not taking the atmospheric attenuation in the account. And if we see the wired link, the alpha is 0.05 dB per meter, or 0.0057 Np per meter, the attenuation. And attenuation of this coaxial line will be 10 log of e to the power minus 2 alpha r, and this attenuation is minus 250 decibels. So we can say that for this distance, 5 kilometers, the attenuation of the wired link is much higher than the attenuation of the wireless link. So this is not always the case that wired communication has lower attenuation, because after a certain distance, when we increase the value of r, after a certain distance, the attenuation of the wired link will become larger than the attenuation of the radio link. I hope you have got the point. If you have any questions, please put a comment below. Thank you very much.